Okay, so first we'll look at length, and then we'll look at area. So geometric probability is basically the probability of an event happening out of the whole area or region that we're looking at. So for example, length probability ratio. So let's say we have this line segment from A to D. What's the probability that if we choose a point randomly that it lies on BC? So
BC divided by 80.
Right, BC over the whole segment. Okay? Okay, so here we have this line segment, and point X is chosen at random on the whole line segment JM. Okay? What's the probability of each event?
4 over.
Okay, so X is on LM. So LM is
4 over 14.
And we're just gonna, for all of these probabilities, we're either gonna keep it as a simplified ratio, or we can change it to a decimal round to the 100th place, so that we can reduce into 2/7. How about the probability that it's on KL?
7
Right?
over 14.
7 over 14, which Adira said, 1/2. And lastly, what's the probability that it's on KM?
11 over 14.
11 over 14. And yeah.
It's really Geom Hon.
Is there gonna be one that's like X is on anything but KL, and then just add it?
Well, that would be easy.
My wheels are turning.
Ten over 76.
Okay, Halley's Comet orbits the Earth every 76 years. What's the probability that Halley's Comet will complete an orbit within the next decade?
0.
10 over 76.
It's just saying like any single decade.
Wait, but when did
10 over 76.
5 over.
Wait.
Whoa.
Well, how long is a decade?
10 years.
10 years.
Can you go for like a second? Doesn't it take seconds?
5 over
30.
30. What? Oh, yeah.
Right.
Yep.
Wait, can you go?
Good. Okay. So what happens when we have area as a probability? Okay, so point chosen at random. So if we want the probability that it lands in region B, we want the area of B over the whole outside area of region A. All right? Yes.
Are we gonna do it where it's like this, but in 3D shapes?
We're not doing volume.
Oh no.
Only area. Only area.
I burned my tongue at the shop at home and it still feels burnt.
Okay, find the area of the shaded region.
Yeah, it's on recording. Oh, we're recording. I did.
Okay, area of the shaded region. So if you recall, we did this in chapter 11, where we're going to take the outside region minus the unshaded region. So first of all, the outside region is going to be pi r squared.
So pi times.
So we're going to take the circle and we're going to subtract the square. So if all the way across is the diameter, which is 20, each of these segments inside would be 10.
Oh, and it's only 45.
Right, all of these are, oops.
Wait, region B is the smaller one?
Well, region B is going to be the shaded area. So we're going to figure out the shaded area, and then we're going to divide it by the outside region,
Wait, do you
which
mean
is the
region A
circle.
is the shaded area?
Yeah.
Do you mean region A is the shaded area?
No. It's B, area of region B, over the whole area of A.
Yeah, but so region.
But
B
I thought that the
would be
black was
unshaded.
what was shaded. Is it the white that's shaded?
No.
The blue shade.
The bluish
Black.
is shaded.
Yeah, that's region A, correct?
Okay,
On the
listen.
paper it's black.
You
Wait,
don't
Great.
You don't need to know. Just think,
On your hero.
what is the shaded region? So it's going to be basically the outside minus the unshaded region. Okay, so what's the outside? The outside is the circle. So the circle is pi r squared. The unshaded is the square. Now, since this is a square, all of these are 10, and then each side would be 10 root 2. So if I do 10 root 2 times 10 root 2, okay, right? Because it's a square, so base times height, and the base and the height are both the same. So I have 100 pi minus 200. Now, I can change this into a decimal at this point, but because my final answer, I want to be able to round to the 100th place. So the probability, so find the probability that a point chosen at random will be in the shaded region. So that's going to be 100 pi. Good. Over 100 pi. Okay. So whatever you put in the denominator, that's like the large outside region. So on our calculator, we could just plug this all in. So you'll need your calculators today. So let me. Okay. All right. I don't see calculators.
Oh, I think mine's dead. Yeah. Do you have an extra or can you What? It's on the red. So you put wait, when it says region A, is region A plus B?
It's like the whole thing.
Okay, so it's just the area of the part over the whole.
Yeah.
You just cancel it out? Wait, is this not like the exact same thing we were just doing? Can't I just be negative 200? You're definitely possible.
Why is there
Okay, so what do we have? 100 pi minus 200, all divided by 100 pi. Right?
Yeah.
Okay, we're going to
Why
round.
is it divided by 100 pi?
What's that?
Why is it divided by?
What's the outside region?
Like
0.36.
The circle.
The circle is 100.
If I got that answer, I would not feel like
The circle as a whole is 100 pi.
0.36. Oh yeah.
No, probability. So the
not 36%.
So it is a 36% chance. I'm just gonna have you leave it to the 100th place. Okay.
We should put it as like a percentage.
I mean, you can just.
That looks
I prefer
more
just to
rewarding.
go to the 100th place.
So percent looks like I actually did something.
All right.
Is this all? Like more specific? Great.
Yeah, it's more aesthetic.
Like,
Okay.
isn't
Yeah.
when there's like an equilateral triangle like that in a circle, the triangle takes up less than the circle?
The triangle takes
What?
up less space than
What
the
does that
circle.
mean?
That's true.
No,
That's facts.
See?
Okay.
No shit.
Okay.
No.
What is the area?
Is it engraved or
The
whatever?
shaded is gonna be
Okay, first of all, the
Okay.
4 is the radius of the circle. So
or I'm saying
the area of the circle is going to be pi times 4 squared,
Really?
right?
How do you know?
I thought that was the
that's not like it doesn't look like it. That's true.
All
It
right,
also
with
might
that?
not be like drop to scale.
Okay, now
Like this piece is small.
with the triangle,
56.
so this is a
'Cause you
30,
remember.
60, 90 triangle. So if the
Yo, it's
hypotenuse is
56%.
4, the apothem would be 2, and this would be 2 root
Yeah,
3.
we're not helping.
So remember, if the hypotenuse is, whatever the hypotenuse
Mark's
is,
not ready for me.
the shorter leg is half of that, and then we multiply by root 2. How does this help us?
Let me do 2 times the
You want
perimeter.
I
Right.
have no idea what's going to be.
So each side is 4 root 3. That means the perimeter is 12 root 3. So we have 12 root 3 perimeter times the apothem divided by 2. Perimeter times apothem divided by 2. Some people say it that way, but it's pronounced apothem.
Yo, what are you doing?
Okay.
Those just handles.
What's the probability then? Okay, take that, plug that into the calculator.
Are exploding.
Okay, remember how I said the seating arrangement isn't
sorry.
working? Okay.
It's not
Plug this in. So I have 16 pi.
I know.
Okay. So we get okay, so the area shaded, we get 29.48 approximately.
Over 12 root 3.
Wait, what's the outside region? The circle. What's the area of the circle?
16 pi.
16 pi. So I'm going to just take this answer and divide it by 16 pi. Okay. So 0.586. So I'm going to round to 0.59.
Isn't asking for the probability?
Yes.
So yes, probability is between 0 and 1. If we want to make it into a percentage, that's fine, but you'll see on the homework I'm going to specifically ask you to leave it at either as a fraction or a decimal place. Okay, probability, because when you work within statistics, generally you like if you take AP stats or something like that, your probabilities are always going to be in decimal form. Okay, next we want to find the probability that a point chosen at random is in the sector with central angle. So here, that's the region we want to find. So how do we find the area of a sector?
Divide the
75 over 360.
In this case. Wait, I'm so confused. So I got here. And then.
Oh, wait, what? Yeah.
Because you're supposed to divide by 16 pi.
Somehow.
It's the circle.
Oh.
Billy did this.
That was fun. Wait, which one's the one where you do like 360 divided by the number of
Wait, in this
sides?
case,
And then you divide by 2.
Wait, in this case,
What's
I
that
thought
for?
you're dividing the circle by the triangle.
No, you're dividing the shaded area over the,
The whole thing.
which is the circle.
Oh, the shaded area.
Was it there?
So what do you get? Yes.
Okay, so the area of the sector ends up being about 65.45. So our probability is going to be 65.45 over the whole circle. What's the area of the whole circle? 100 pi. So I'm going to take the previous answer, question, oops,
The second one.
0.21.
Oh, that's because it did that.
So 21% chance.
Do you want us to round it like that?
That's what I have you do for the homework
Oh.
on the worksheet.
So like round to the nearest 100.
Yeah.
I'm so glad we don't
Isn't
have
that
that
not
one
like the
before.
worst?
Me too.
Okay,
Is
the
that
last one. So
We
find
should
the
all take
probability.
guesses on what it's gonna be.
It's gonna be 11.56. 15.
Who's giving?
It has to be between 0 and 1.
It's gonna be
What?
0.23.
I
I'm
don't
guessing
remember
the
the
answer.
first thing in this unit
It's
said
like
probability is
20.
Can I guess the answer, please?
Oh, 9.
4.86.
1, 4.
Okay, how are we going to find that shaded
4.86.
region?
0.16444.
You're joking.
Okay.
4.9.
4.1.
Actually,
Yeah.
like what this is.
Okay,
Oh
my god.
so it's a regular pentagon.
This is the one where you do.
But if we can just do the sector, like do one sector
Wait,
what?
and take away.
The answer's for sure gonna be 4.86.
So for my shaded region, I'm going to take the sector minus the triangle. Okay, if it's a pentagon, 360 divided by 5 gives us 72 degrees. So the sector is going to be 72 over 360 times pi times 10 squared.
Wait, don't you divide it by 2?
Okay, we're going to divide it by 2 so that we can work within here. So if I draw the altitude, this is going to be 36 degrees. All right, how do I find the area of that triangle? Base times, can we do base times height divided by 2? But I have to use some trigonometry. So I will call this will be,
Oh, is it tan 36?
Oh.
not tangent. How about
No,
Sine.
sine 36 equals x over 10. So that means sine of 36.
Wait,
Isn't
but
Oops. I'm in radians, sorry. There we go.
how do you
Okay.
copy it like that?
You just use the
the
up
up
arrows.
arrow.
That's literally it.
Yeah.
Great.
64%.
Okay, so x is about 5.87. So I'm going to double that.
Why?
So the whole side,
Oh.
so this whole side is 11.7.
What did I say?
So don't you want to multiply that by 3 to find the perimeter?
Well, we don't have to. Okay, listen.
Oh, right, base times height.
I could just do base times height divided by 2. But I don't know what the height is. So I could either do Pythagorean theorem or I could just now do cosine. So if I do cosine of 36 equals a over 10.
What?
Or just a strange specimen.
Okay. Are we alright with that? Lauren?
Yeah.
Yeah? Okay, so we're going to subtract the triangle. Okay, so this we're just going to all plug into the calculator. And that just gives us the shaded region. Okay, but don't worry, we already did all the hard work to find everything else. So let's see. 72 over 360 times.
What did you write after that? 0.76.
Oopsie. Oops. What do you mean? That's the A.
Does it wait in that? Wait, in that little.
No, it says times
8.09. I was just running out of room. Oopsie. Press enter too quickly.
Whoa.
Okay, I get 15.279.
Would that be like extra credit?
Maybe.
Yeah.
I swear there's an
Okay.
easier way to do this, Miss Casey.
Okay, if you find it, you let me know. Okay. All right. What was the area of the sector? So I just want to take this,
11.7.
but this is just, okay, so this was how we found the area of the sector minus the area of the triangle just gave us this whole thing, but what's the whole region? 100 pi.
Oh, like this circle?
Yeah. So I'm going to take this and divide it by 100 pi.
It better be 0.16.
Oh my god.
I was like on the coast.
I could have guessed that.
What was our guess?